what we are starting is our unit on waves. All I want you to think about, because a wave is a periodic, repetitive motion, is all the different things in your life that have a repetitive motion. Think of as many as you can. And then think of things that don't repeat, which is a majority of things, right? So I want you to make a list of all things that are periodic, meaning repeating motion, and all the things that are non-periodic. The bottom half is on simple harmonic motion. We're doing a simple harmonic motion lab today. I don't want you to fill out the bottom part. We're going to fill out the bottom part together off of the list that you created for periodic motion, because periodic motion is a big umbrella for different types of repetitive motion, one of which includes simple harmonic motion. Let's start with group number 1. Do you have an example of periodic or non-periodic?
I have a periodic example.
Good.
Actually, well, yeah, I did the minute hand on the clock.
Sure. I'll just put clock in general. The rotation of the hands on a clock. Perfect. Group 2, what did you come up with?
Waves in the ocean, or examples of periodic.
Ocean waves. Awesome. I'm going to move over to this group here. So group up front. You don't have group number, but I'll say group 3.
I feel like ocean tide.
Tide. No, that's so ocean waves and ocean tides are different.
Oh, sure. Like,
So the rise and the fall of the tide. Good. Let's go ahead and go to Mason.
breathing.
Breathing.
You guys get
Awesome. Okay, let me go up to this group in front. Ian, you had one?
muscles around the heart beating.
The heart beating. Good. Did you have a different one, Sam?
Oh no.
Group it back, Marina. Walking.
No.
Dude, you're kidding.
The back and forth motion of your feet. Awesome. Let's go to group 7. Water molecules are moving. So I'm going to put that under non-periodic motion because they kind of move in a sporadic way, right? So water molecules, or even just molecules in general, I'll just put molecules in general would be non-periodic as they vibrate. Group 8, did you have one? What? What was it? Planets. Planetary motion. Perfect. Good. All right, we got a lot of periodic motion. Any non-periodic motion? Steffa? The earthquake. Good. So the shape of an earthquake. But what I do want to say is that the earthquake does create waves on the surface. So I'm going to put earthquake waves here because we're actually going to learn about earthquake waves, especially since we live in California. It's important to understand that in our waves unit. So other non-periodic motions. Avery? Sorry, Adele. Sure. Let's see. Food in a blender. Any others? No? Everything else is non-periodic, right?
I don't really.
Kyle? Blinking. Kind of random. Good. Isn't Alex?
Like phone notifications.
What?
It's not car driving.
Car. Car can drive in many different directions. Avery.
I think I'm a little confused about like the actual difference because I feel like a lot of those could be non-periodic.
So something that is, for example, I like the car driving. Blinking, you could have periodic blinking, but generally our blinking is random, right? It doesn't happen regularly in a pattern. And when we talk about periodic motion, it means that it's like a regular pattern of events. Any other non-periodic? I'm going to add a few that I really liked from the previous classes. They said rain, non-periodic. They, what was another one? They, similar to car, they put a plane flying. And they also included molecules or electrons and protons would be non-periodic. So under the umbrella of periodic motion examples, we've got something more specific, which is simple harmonic motion. And simple harmonic motion has certain characteristics. One, it has something called an equilibrium. It means that there's a center position in which an object will fluctuate. It'll fluctuate above the equilibrium and below the equilibrium, but it always returns back to equilibrium. So of these, let's think about which ones follow simple harmonic motion. So first of all, let's think about the clock. Does it have an equilibrium? Does it fluctuate up and down between that equilibrium? How many of you say yes? How many of you say no? So, how many of you didn't respond? I got most not responding. Let's think about the clock. A clock rotates, right? So, if it is rotating, sure, it's rotating repeatedly around and around and around, but is it rotating around in equilibrium? Yes, definitely. So I would say a clock, you can put that under simple harmonic motion. Ocean waves, they come in, they go back out, another wave comes in, it goes out. Does it travel along an equilibrium? Is there a center position in which ocean waves travel? How many of you say yes? How many of you say no? So I would have said no for this one. The reason why is because we have waves coming in from faraway parts of the ocean. It's going to go back out, but it's not going to have any specific equilibrium point in the ocean, right? There's no center position in which waves travel out and in, out and in. So for ocean waves, I would say no, not simple harmonic. But what about the tide? The rise and fall of the tide. Does that have an equilibrium? Is there a point where it goes up the equilibrium and down? How many of you say yes? Good, definitely. Tide would be simple harmonic motion. Breathing. Would breathing be simple harmonic motion? How many of you say yes? How many no? This is a hard one. Breathing, when you're talking about the air in your body, I would probably say no, but the up and down of your lungs, that does kind of seem like simple harmonic motion as your lungs go out and then in. I was thinking the same thing about the heartbeat and breathing. As your heart beats, it goes out and in. There's a center position in which your heart goes out and in, right? So that one's a little ambiguous. For these two, I think there are different ways you could think about it, where it could be simple harmonic or not simple harmonic, depending on what aspect you're thinking about. Motion of the feet as you're walking. Is it simple harmonic motion? Yes? No? I would say no, but if you're thinking about your hips being your equilibrium, as you walk back and forth, your legs are like pendulums. And a pendulum is simple harmonic motion. Now, as we continue to move forward, there's no equilibrium point, right? So I would say no for this one, but we are going to talk about a pendulum which swings back and forth along the center, and that would be a simple harmonic motion. What about planetary motion? We already talked about the clock. So planetary motion is another cyclical motion. And then earthquake waves. Earthquake waves, you're going to learn about, there's 3 different types, but you're going to learn about S waves. And you're going to learn about P waves, which move back and forth like this. So for earthquake waves, do you think that that would be simple harmonic motion? My equilibrium of the S wave would be like that. And then if it was a longitudinal wave back and forth, you would have an equilibrium right at the center, up and down. So this one would be simple harmonic